Okay, I have redrawn my shunt my shunt circuit, and I have redrawn my armature or rotor circuit. Okay, left side here I have a more conventional circuit. I have a symbol for a battery here representing 120 volts DC. Okay, which we know from the little bit of experience we've had in lab, okay, that this is the negative polarity on the top side of a battery and the positive polarities on the bottom side. Okay, a little bit different than I was dealing with it before with the vertical schematics. Okay, so current travels, let's say this time that it travels from negative, okay, through the shunt wire resistance and the coil all at the same time, and back around to the positive side of the battery. Okay, I could have said current flows this way, and the math would have turned out the same way. Voltage drops, Ohm's law, Kirchhoff's law would have had the same answers with the same polarities, as long as you observe the rules of polarities. Okay, so this is the shunt circuit right here. I've got a complete path for current flow. I show you the parameters of the components of the field circuit, which is this side right here, you know. And how about if I make that clear? Okay, this is the field circuit. On this side, I've got the armature circuit. Right here. Okay. Both are drawn in a method that we're very comfortable with, I guess, from the early circuits, such as Introduction to Electrical. All right, so I've got here, I represent my power supply as a battery, but I've got an arrow through it. Okay, that convention indicates that this is a voltage. Okay, call it a battery if you wish, but the voltage is variable. That's what the arrow means. Okay, now in our trainer, instead of having a battery here, what we have is we have a what do you call it? Not a rheostat. Variac. Excuse me. Okay, so I'll do that. I'll put a note of that right here. That we get that in our trainer by way of a variac. A variac is a variable transformer. Okay, variac. If that's a new word for you, okay, commit it to memory. I'll put it on an exam. Okay, so what we do is we have connected our variac to the rotor. The rotor is made up of wire, okay, and it's got a piece that is mounted on bearings so we can rotate it. All right, I can rotate this thing. Okay, my electrical is connected, okay, to the rotor, okay, through the brushes. This represents a brush. And this represents a brush. And the two brushes are actually sitting on a commutator. Okay, commutator is something that's closely akin to a slip ring, but, you know, they ain't the same thing. There is a difference between a commutator and a slip ring. Okay. The purpose of drawing the coil separate from everything is that the inductance, the coil in the armature, produces the magnetic field that the armature needs to form a torque when this magnetic field interacts with this magnetic field. However, when it comes to troubleshooting a DC motor, this is the big deal right here, okay? The counter EMF. So let's take a look at this. I don't want to confuse people, but I'm going to run the risk of doing so. So my current, I'm going to say in this circuit, is traveling from negative to positive. And I will say the same thing here. Okay, that's pretty sloppy eye right there, right? Okay, maybe that'll make it a little bit better. Okay, so this is a circuit which might give us a little bit better understanding. And there are two circuits, okay? In fact, I think I can safely say that we've got 1, 2, 3 different circuits in our DC motor. We have the shunt circuit, we have the armature circuit, and the one that we haven't talked about is the series circuit. If time avails, we'll talk about the series circuit and the series configuration. So, where does this resistance right here come from? That resistance is part of the nature of copper wire. All wire has resistance. Big wire tends to have, fat wire, large diameter wire, tends to have less resistance than small diameter wire. But it's always present, and it is the reason that wire gets hot. Okay, current flowing through the shunt wire makes the shunt circuit get hot. Current flowing through the rotor wire of the armature makes that circuit get hot. Now then, in the counter EMF part, the rotor, this is the rotor, okay? It too will get hot due to eddy currents, and I'll say the same thing about the inductor, okay, in the shunt circuit. Okay, I'll let you absorb this. I'll let you take notes. There it is. You should be able to draw this circuit when exam time comes. And that cannot be far away since we are in, we're headed toward the tail end of this semester. So if you have questions about this, you can ask me about it. You can ask Alex about it.